Let's talk about the print function. The print function is one of Python's most commonly used built-in functions. Its purpose is simple. It outputs information to the screen. Specifically, the print function can display text, which in programming is called a string. A string is just a sequence of characters enclosed in either single quotes or double quotes. For example, in the code shown here, print hello world. This tells Python to display the phrase hello world on the screen. This is often the very first program beginners write. Think of a function like a magic box. You give it something called input, the box does some work inside, and then it gives you back an output. The important part is, you don't always need to know what's happening inside the box. You just need to know what goes in and what comes out. That's why functions are so powerful. They let us reuse code without having to repeat ourselves or worry about the details every time. Here's a simple example of how a function works. This function is called add2numbers. It takes two inputs, labeled here as number 1 and number 2. The function performs the task of adding those two numbers together. Once the calculation is done, it produces an output, the result, which we're calling total. So the process is, give the function some inputs, the function does the work inside, and then it gives back a result. This is the essence of how functions work in programming. They take input, process it, and return output. When working with functions, two important terms to know are parameters and arguments. An argument is the actual value you give to a function when you call it. For example, if you call a function to add numbers like add2numbers, open parenthesis 3, 5, close parenthesis, the numbers 3 and 5 are the arguments. A parameter, on the other hand, is more like a placeholder. It's the variable name you write inside the function definition that will receive the value when the function is called. So if the function is defined as def add2numbers, open parenthesis x, y, close parenthesis, then x and y are the parameters. In short, parameters are the labels inside the function, and arguments are the actual values you pass in. We'll come back to this later in the semester when we go deeper into writing our own functions. So let's break down what's happening in this example. The word print is the function name. This tells Python which function we want to use. Inside the parentheses, we have hello world. That's called an argument. It's the actual piece of data we are giving to the function. So when we run this line of code, Python takes the argument hello world, then passes it into the print function, and then the function does its job, which is displaying the text on the screen. This simple example shows how a function has two key parts, the function name and the argument passed into it. Here's another example of the print function, but this time with multiple arguments. Notice the code, print open parenthesis, welcome, to, Python, close parenthesis. We are passing three separate pieces of text into the function, separated by commas. What Python does is combine them into a single output, automatically adding spaces between each argument. That's why the result appears as welcome to Python, with spaces in between, even though we didn't type the spaces ourselves. This shows how print can take more than one argument and display them all together in one output line. Now let's look at something called string concatenation, which simply means joining strings together. In Python, the plus operator isn't just for numbers, it also works with strings. In this example, we're using the plus operator to combine three strings. Python glues them together exactly as written, without adding any spaces. That's why the output is welcome to Python, all stuck together. By contrast, when items are separated with commas, as we saw in the previous slide, Python automatically inserts spaces between them. That's why the output in that case is welcome to Python, with spaces between the words. Sometimes we need to include special characters inside a string, things that normally wouldn't be allowed or would confuse Python. That's where escape sequences come in. An escape sequence starts with a backslash followed by another character, and it tells Python to treat it in a special way. For example, \n inserts a new line, so the text moves to the next line. \t inserts a tab space, which is useful for formatting output. \\/ lets us print an actual backslash. \double quote allows us to include a double quote inside a string. \single quote allows us to include a single quote inside a string. These are important because they give us more control over how text is displayed, especially when formatting output. Sometimes we need to write very long strings, and it can be difficult to keep them on a single line in our code. Python allows us to split a long string across multiple lines by placing a backslash at the end of the line. In this example, we're breaking a single print statement into two lines. Even though the code spans two lines, the backslash tells Python to treat it as one continuous string. That said, this approach is not generally recommended. Using a backslash to break strings can reduce readability and may make debugging more difficult. So far, we've seen how the print function can display text and strings, but print can also handle expressions, calculations that Python evaluates before displaying. In this example, Python first works out the expression 7 plus 3, which equals 10. Then it prints the text sum is followed by the result of that calculation. This shows that print isn't limited to fixed text. It can also display the results of calculations, which is very useful for checking values while a program is running. Python also has something called triple quoted strings, which are written using 3 single quotes or 3 double quotes in a row. Triple quoted strings can span multiple lines and are often used for long blocks of text or for documentation inside code. However, for now, we are not going to use them. They can be a bit confusing at the beginning and aren't necessary for what we're learning right now. We will come back to triple quoted strings later in the semester, once we've built a stronger foundation. So far, we've seen how Python can display information using the print function. But programs often need to do more than just show information. They need to interact with the user. That's where the input function comes in. It's a built-in function that allows us to ask the user for information while the program is running. In this example, Python displays the prompt, "What's your name?" and then waits for the user to type something. If the user types Paul, that value is stored in the variable name. When we later call print name, Python prints out the stored value, Paul. One very important thing to remember about the input function is that it always returns a string, no matter what the user types. In this example, the program asks for two numbers. The user enters 7 and 3, but instead of treating them as numbers, Python stores them as strings, basically as pieces of text. So when we try to add them together with value 1 plus value 2, Python doesn't do math. Instead, it concatenates the two strings, producing 73. This can be confusing at first because it looks like math, but Python is really just sticking two text values together. In the last example, we saw that the input function always returns a string, even if the user types a number. To actually work with numbers, we need to convert that string into an integer. Python gives us a built-in function called int that does exactly that. On line 10, when the user types 7, Python stores it as the string 7. Line 11 converts the string 7 into the integer 7 using the built-in function int. So the key idea is this. Input always gives you a string, but wrapping it with int lets you work with integers. We just learned that we can use the int function to convert a string into an integer. But what happens if the string isn't actually a number? In this example, the program asks for an integer, but instead of typing a number, the user types hello. Python attempts to convert the string hello into an integer. Since hello is not a valid number, Python doesn't know how to handle it. The result is a value error. Specifically, Python says, value error, invalid literal for int, with base 10, hello. This is Python's way of telling us, I expected digits that I could convert to a number, but I got text instead. This example shows why we need to be careful when converting input. If the user types something that isn't numeric, the program will crash with a value error. In Python, we can add notes to our code that the computer completely ignores. These are called comments. A comment is a piece of text that starts with a hashtag symbol. Everything written after the hashtag symbol on that line will not be executed as code. Comments are meant for humans, not the computer. They are a way for programmers to explain what the code is doing, leave reminders, or make the program easier for others to understand. And this is really important. Good documentation can be just as valuable as the code itself. Code tells the computer what to do, but comments help people understand why the code is written that way. So whenever you see the number sign symbol, think of it as a little note for programmers, not instructions for Python. Now let's talk about some best practices for writing comments in your code. First, it's a good habit to begin a program with a comment that explains its purpose. Think of it as a note to your future self or to another programmer who might need to understand or modify the code later. Next, when you define a variable, it's often helpful to add a short comment explaining what that variable represents. For example, if you have a variable called tax rate, you could add a comment to remind yourself that it stores the state sales tax percentage. You should also place brief comments before major sections of code to explain what those sections do. This way, anyone reading the program can quickly see the structure and purpose of different parts. Finally, comments are especially important in complex or tricky sections of code. If the logic is not obvious, a clear comment can save a lot of time for anyone trying to understand it later. Remember, comments don't change how the program runs, but they make it much easier to understand, maintain, and share. We've talked about how important comments are, but it's also possible to overdo it. Too many comments can actually hurt readability instead of helping it. For example, writing a comment for every single line of code is unnecessary and can make the program cluttered. Instead, we should focus comments on the places where they really add clarity. Another key idea is writing self-explanatory or self-documenting code. This means choosing clear variable names and structuring the code in a way that almost explains itself. For instance, instead of writing x equals 5, then adding comment to say number of apples, we could simply name the variable apples and write apples equals 5. The code now explains itself without the need for a comment. So the goal is balance. Write enough comments to explain the tricky parts, but also write code that is clear and easy to understand on its own. In programming, we often use values that shouldn't change while the program is running. These are called constants. Python doesn't enforce constants like some other languages do, but by convention, we use all caps variable names to indicate that something is meant to stay the same. For example, here we define pi equals 3.14159. Since pi is a mathematical constant, we don't want it to be reassigned to something else later. Using named constants makes code easier to read and maintain. If you need to use the same value multiple times, like pi in a formula, you only need to define it once, and the name makes the purpose clear. So remember, when you have a value that shouldn't change, make it a named constant. Thank you. This presentation was prepared by June Lee with the assistance of AI technology.